Researchers have just pitted a quantum computer against a classical computer, showing that quantum computers are becoming more realistic, but exactly what they would do isn't what you think. At the moment, quantum computers have no household value. The processors need to be kept at temperatures just above absolute zero, which is basically the vacuum of space. They don't like sound or disturbances, and they're easily knocked out of a quantum state, leading to unreliable calculations. People tend to think that a quantum computer is just a roided up classical computer, but they are fundamentally different and will have different functions. Quantum computers, at least in the beginning, will probably only deal with model simulations. Modern day computers use binary bits. There are two options, 1 and 0, and there can only be one at a time. Quantum computers can exist anywhere between 1 and 0 in a kind of non-binary fluid state. This is called superposition, and it basically means that a quantum computer isn't slowed down by only having two options. For example, instead of using a trial and error process, where a classical system has to figure out the best course by trying each option, quantum computers can calculate all those possibilities at once, meaning that incredibly complex problems can be solved instantly. In the experiment at IBM, they used a 127 qubit processor to model the spin of a material and how it responds to magnetic fields. It's actually a model used pretty often when studying magnetism, but certain parts of the problem are too difficult for a classical computer. IBM's processor calculated it within 1,000th of a second. We have a long way to go before quantum computers become usable machines, but this is a pretty cool step in the right direction.